Okay, thank you so much everyone for coming to join this session, the first ever TiDB user group APAC event. So I'm Neil, I'm the host today. So today is a very honored to have all these panelists coming join us. It will be a 2.5 hour full session, a lot of technical insight and experience sharing from the panelists. So really looking forward to all the sessions coming over very soon. So today we will start with the TiDB user group introduction, followed by Sean Marr will share with you how HTAP help you in growing your business, and Ninja One CTO and engineers will share with you the scaling their database with Kubernetes and TiDB. So the last but not the least, it will be really the one we are looking forward, which is the fireside chat to talk about how the technical leaders has been really dealing with the hypergrowth business challenges in terms of the technical challenges and architecture challenges. So without any hesitation, let's kick it off. So what is TiDB? To really explain you what is TUG, the TiDBs had to come first. So TiDB is an open source new SQL database that support hybrid transactional and analytical processing workload. It has all these 4 features available, which is horizontal scalability, strong consistency, high availability, and it speaks MySQL. TiDB user group is really initially was meant for how to aggregate all the TiDB users coming to the community and share the insight and knowledge to each other. And while we're developing the TiDB user group, we realized there are not so many communities really looking up for database and big data technologists. That's where we formed this TUG. This TUG has been there for a year plus already, but TUG APAC is the first time ever we kick it off in this region. So what TUG can really help is, it helps you exploring the cutting edge technology for the big data and database and many other technologies, empowers users with quality content, and together we build a community with all the talents we have in this region, which is a big one. And also with all the TUGs, we make like-minded friends and share technical insights, acquire cutting-edge knowledge, and also really to have you come into the community and speak about your experience and share your thoughts to be the thought leaders in the community and across the region. Every organization has to come into a charter or goal. So the goal for TUG is really connect users and we grow together with the community, with your knowledge, with the society. And the vision is we want to build a pioneering, active, self-governing global community for the database and big data technology for Asia Pacific and also for global community. Last but not least, we keep the principles to be open, respectful, and also positive to each other, and to really just share the knowledge, no matter who is right or wrong, we just share the objective thoughts on what do you think, right? In terms of how the TUG has been really formed, we have TUG co-leaders are really leading the vision for the community, and the ambassadors are the ones who also, together with the leaders, create a lot of content and speak in the event, read articles to really spread the knowledge to the community. And also, we welcome more people joining to the community, become the members, so that because this is a kind of annual election for all these leaders and ambassadors, hopefully we can elect the better ones in the future and return the better ones for the ambassador and leaders. So we are very honored to actually have the first chapter of TUG APAC, where we have the leader is co-founder and CTO of Ninja One, which is Sean Chong. We also have 2 co-leaders. One is from PayPay, Karen, and the other one is from Grab, Changjun. So we also have already have about 10 plus ambassadors from across all these companies. And they actually, to give you some insight on who they are, they actually have some video to really I want to play this video and share with you what do they think about this community.
Hello everyone, my name is Karan and I'm working at PayPay as a platform engineer. I'm really glad to be part of TiDB user group and I hope to see many of you joining the TUG community. TUG, connect and grow. Thank you.
Hello, I'm Colin, CTO of Blue City. TUG, connect and grow.
Hi, I'm Chang Jun. I work at Grab. Welcome everyone to TUG to share and discuss technology.
Hello everyone, my name is John from Indoas.com. We're the only CPF, SRS, and cash digital wealth manager in Singapore. Thanks for having me in the TUG group. I'm willing to connect users to companies who have been on PingHab or TiDB solutions to share their personal experiences and team experiences to help you build a robust solution for your business requirements. Looking forward to the next event. Thank you.
Hi everyone, this is Jin Lu from Sherry Technology. I'm here with TUG. TUG, connect and grow.
Yeah, so really thanks to all the members to really prepare this video for of you. And again, the slogan for TUG is connect and grow. We hopefully to connect all these technologies in the region, the best talent in the region, and really grow with you and the community. So absolutely, we have a lot of benefit to be part of the community where whatever content you contribute and events you speak with, there are points and there are benefit coming after the points. So we don't want to really talk too much about this one, but there is there for you all the time. Every year we elect the most outstanding advocate and also most valuable advocate from the community. No matter who you are, whether you're a member or ambassadors, you are qualified for this outstanding award. There are tons of benefit coming after on top of the benefit you have from the community. We also organize a lot of tech sharing. Again, this is first ever for this region, but we will have a monthly event coming over. I will have actually some news for you by the time this session gonna coming to the end for the whole session. And also, once COVID-19 is gone, we're gonna have a company visit. Absolutely, we have fireside chat and also the face-to-face talk to PingCabers, employees from PingCab to share the best knowledge from the industry. And last but not least, if you are interested, after the short introduction of TUG, please scan this QR code and join the Slack channel, looking for the TUG-APAC. So for this Slack channel is for our TiDB community overall. There are about 2,000 plus people registered already. We have dedicated channel for APAC. So feel free to chat and share your knowledge there. And also anything you are interested, feel free to chat. Without further ado, I will really want to kick off the whole session with bringing in Sean Ma, who is the senior technical director from PingCab. We'll talk about how HTAP help you in growing your business. Thank you so much. Sean, over to you.
All right, let me share the screen.
Sean, okay, cool. I can see your screen. Yeah.
All right.
Nice. Over to you, Sean.
Okay. Okay, today's topic is how HTAP helps you in growing your business. I'm Sean Ma. I'm the Senior Technical Director for the analytical products from PingCab. Previously, I worked for Quantcast, NetEase, and my interest is in big data and distributed system. Okay, first, let me introduce TiDB and PingCap. TiDB wants to be a single source and truth for for both TP and AP. And TiDB itself is an open source cloud native distributed database. And we already have a lot of adoptions around the world. So here's some of the logos for some of our customers. These are not all of our customers, but these might be some you are familiar with, including like Squares and PayPay, and also WeBank and Dailymotions. Those big names. And for the company behind the TiDB is PingCap. We provide enterprise level and cloud-based services for TiDB database. And so you can count on TiDB and count on PingCap for its database solution to simplify your database infrastructure. So first, what is HTAP? Let's back to the topic, the HTAP itself. So HTAP is a simple term that invented by Gartner. So it is a concept to describe a simple concept about the single database or single system can process both transactional workloads and analytical workloads. So for TP, the transaction workloads, um, it has some characteristics like they mostly using row format and they need to be updated in real time. And most of the TP workloads are very high concurrency and they need consistency. And most of the time, they only touch a few rows each read or each transaction. Um, they most likely are current data instead of the historical data. For the AP parts, it's quite different. Most of the time, they use columnar store, and the update is in batch. And the column store is not very good at high concurrency processing. So most likely they are like reporting and low concurrency workloads. Um, and the data is being processed in large batch. A lot of time they store the historical data and process the historical reports. Because of that, the two goals for transactional processing and analytical processing are quite different. And so we make different databases traditionally. And because of that, so you have a system platform like that, like this graph. You have your database, TP database in the very front, at the very front. They are OLAP database, and they are might be each of your business units have their own database, so they are not like connected together. And we use ETL pipeline to move your data from the ORTP database into your data warehouse or maybe data lake, like Hadoop in the graph. And inside a Hadoop system, you might do some analytics workloads, and you might also refine your data and to make some models or train some data. And these results might be output to some serving database and serving platform because Hadoop or data lake itself is not very good at data serving. So you have another ETL pipeline to output those results to ORTP database or to something like HBase. There's another routes for the real-time processing. You probably output those like bin logs or CDCs into Kafka, and the Kafka syncs those things into HBase. And the HBase part provides you a scalable data storage and can be processed in real time. And these real-time routes and serve some of the online application or internally data serving purpose. So because of you have multiple purpose for your single data platform, and some are real-time, and some are TP-ish, and some are AP-ish, and so you have a different component for your data platform like this. So why we need HTAP database? Because of the boundary between the AP and TP is quite blurry now. Sometimes you have like TP-ish use case, TP-ish but AP use cases. For example, you have comprehensive query platform requirements. that you need to provide both reports and high concurrent short queries at the same time. Um, and sometimes you have APHTP use cases. Say that you have to analyze and optimize your online transactional business in real time. Also, or you want to real time analyze the cross BU data services. Say that you have warehouse business units and you have sales business units. You need to bring them together to have some unified report for the combination data of sales and the warehouse or the logistics. So in these cases, the HTAP will provide you real-time ability to empower those like real-time scenarios. And also at the same time, because you have real-time analytics on your fresh data, so it can provide your business agility. And also at the tech side, the data platform could be combined all together. So you have more simplified data architecture. And also at the same time, that will reduce the maintenance cost. So let's check in more detailed examples like this. So here's the graph that listed some of the use cases might belongs to different categories. For the very left hand, you have the online order services. So by all means, the online order services are those like transactional services and online services. And for those services, if you want to choose a database, that these databases need to have um, some features that provides those online services. Say that you need to update your orders and you need to locate detailed orders, say by the shopping carts or by a user ID. And also it needs to change those data in very high concurrence. So for a database that support online order services, that you need a index, the fine grain index, instead of those like a coarse grain index. And it needs to be support high concurrency, and also it needs to support real-time updates. So these three features are typical provided by a ORTP style database. Let's look at the very right end, a sales history report. So by all means, this is a analytical workloads and analytical services. So if you need to choose a database for this service, then it needs to be scalable because you need to store the historical data, and it might be in a very large volume. And also it needs to be in a column format because the column format is almost the industry standard for analytical services. So for those intersection of those two circles, this is either not to be very typical TP workloads or neither not very typical AP workloads. So what are these? For example, you want to have a real-time charts for your promotion campaign. You want to show your users that what's the real-time charts for the best-selling items at a time, and it needs to be refreshed like from in 1 minute bias, in 1 minute interval. So for this specific service, you need a column store to have like a very high, very good performance for reporting, query execution. And also at the time, you need to sync your data from the TP database to have the latest user orders or latest purchase informations. So for these services, you both need a column store and also the updatable, real-time updatable ability. And similar, the real-time charts or real-time campaign adjustments, these are very similar thing. Another example is like unified query platform. Say that you have different data silos from your TP applications, and you need to bring them together to form something like a real-time data warehouse or the ODS system or data hub, something like that. And you provide a single platform to store all those different business unit data and to provide the analytical on top of that. So if you want to sync data from the TP side in real time, then this database need to be able to update data in real time, and you need to provide something like point queries to locate specific records. Then you need the fine-grained index, and if you also want to provide a column store, provide a report, then you need a column store. And the data need to be scalable because you sync data from different business units, and the data might be very large volume. So for such kind of services, that it requires the database to be equipped with the abilities from both the TP workloads or the AP workloads. So why people do have not built such database like 10 years ago something? Because to meet both requirements from both workloads are very hard. Firstly, if you want the scalability, it is quite mature that for analytical services or for data warehouses that they use the scalable technology to build their database. But for TP side, um, if you want a TP database or a SQL-based relational model database to be scalable, it's not very easy work. Only like recent years that people are investigating the new SQL database. So from that time, you can say that TP, scalable TP is something like to be realistic. For processing both workloads at the same time, you need to support both database data formats, say the row format and column formats at the same database. Otherwise, the performance will not be very good. Um, Besides that, you need to avoid the workloads interference because for AP workloads tend to use grab all the compute, both compute and storage resources at the same time, and to process a query as fast as it can. But TP workloads need to be very stable and needs to be maintained in very low latency. So if you run those both queries, both type of queries inside the same resource group, they it might interfere each other. Um, if you have a database that equipped with both the columns formats and the row format, is it a HTAP database? I think not. Because if you want to analyze the data in real time, the column store needs to reflect all the changes in the TP database in real time. So you need to solve the data synchronization problem, and so that you can analyze the fresh data. So let's talk about the TiDB itself. So TiDB 4.0 is the version that for HTAP processing. So firstly, TiDB itself is a scalable database. It's a distributed database that can scale to hundreds of machines and to store a large volume of data. And it has a lot of proven use cases in the finance areas. So as you might know, that finance business are like most restricted business for those database use cases. Um, in 4.0 version, it equipped with powerful analytical engines. It's an engine that called the TiFlash. We will go deeper for this part later, and it's a natural fit for the data hub use cases or for the real-time data applications because it can be updated in real time, and it looks like both a TP database and also with a column engine. So you can it will be very easy to think data from all different data sources into TiDB. So for the new engines added into TiDB 4.0 is the column engine called the TiFlash. And the TiFlash is a real-time updatable column engine because a lot of the traditional column store is like could be only updated in batch. But TiFlash itself is able to catch up the speed of transactional workloads and to reflect all the changes in real time for the column store. And also, together with the TiFlash engines, then TiDB itself now it have both row-wise formats and column-wise formats. So you can process the different workloads on the same on top of the same database. And also, the column store and the row-wise store are using different machines. So that means the workloads have no interference when they run together. And also, it has a consistent data replications. So each time you have a transaction happens in your row formats, and at the same time, you are guaranteed to read it back from the column store. There's no like a queryable window, something like that. Once you submit a request for the column store, it ensures to return you the data you write to the row store before. Also, it has a vectorized engine to speed up the query itself, and it also does not require a user to write queries that points to a specific engine, because the query optimizer itself can judge if a query is better for the column store or for the row store, or they can be combined in a single query. So that can all be done with the help of an optimizer, and user does not need to know that which engine to use when you submit a query. So let's examine the architecture of TiDB itself. So for on the top of the graph is the TiDB TiSpark, the blue rectangles. So this is the compute engine for the TiDB, and the TiDB here means the TiDB server. It's the compute engine and the computation resource for the whole database. And also you can connect the database onto the Spark. So this is what TiSpark means, that you can read, you can perform analytical queries directly on top of the storage engine. And for the bottom sides, there are two types of nodes. For TiKV is a row engine for the database. The database being sharded in the range sharding. So each of the range shards have multiple replications, and for each of the replications, it's been connected with the raft algorithm, consensus algorithms. So we call the shards regions. So for here in the graph, for region 4, it has 3 replications on different TiKV nodes. And there are another extra replications on the column store side. You can see that there's a dash line connect from the TiKV to the TiFlash nodes too. So that means that this region are replicated using the raft algorithm, and to write the data from the row store formats into the column store formats. So that's the way that we copy and replicate the data in real time. And because of that we're using the different 2 sets of the nodes. So when we execute analytical queries, there will be directly points to the TiFlash nodes and computed on the TiFlash nodes, and it will not interrupt anything on TiKV side. And why we use dash line here? Because the TiFlash nodes connect to the TiKV, connect to the whole cluster in a learner row, which means no matter what happens in the TiFlash nodes, it will not interrupt the TiKV nodes by all means. Even if the TiFlash nodes are down, TiKV can continue to process your online business. Why we still say that under such design, we still can provide the fresh data or provide something like consistent data read, because the raft algorithm can provide you something as a learner read or follow read. By this algorithm, each time we provide the read services on the column store, we have a simple check if we are up to date, the data are up to date with the latest snapshots on the TiKV side. So this simple check is very, very small, and it's a single RPC with the log version, log progress, and the region ID, something like that. So it's a very lightweight check request, and by that the TiFlash knows that if it is up to date to provide consistent read services. So for the scenarios, the very simple and easy to think about is the TP and AP one-stop services. And some of our users are using TiDB to combine their different services. Say that previously without TiDB, you might have a MySQL here for your online business, and also a analytical database, and you have an ETL pipeline, and to move data from MySQL onto your into your analytical database. And for the online business, they directly connect to the MySQL services or to your OLTP database. And for the BI or for the reporting services, they connect to the analytical database. But after applying TiDB, and then you can have those two services combined into one. And the row store answer the OLTP use cases, and the reporting services are connected to the column store. And besides the simplification, also you eliminated the offline batch, the ETL workloads. Previously, you provide your report based on previous data, probably like an hour before, or even 1 day or 1 week before. So that's very common cases. But after the TiDB adoption, then you can have all your reports in real time. So besides that, some of our users are, they already have their very complicated data platform before they introduced TiDB. So some ask us if TiDB is still a valid thing inside their data platform. So yes, why? So besides the simple case that I introduced previously, you can also integrate your TiDB together with your data warehouse or your data lake solutions. So people use TiDB as a real-time layer. They have all their data ingested or directly connected TP use cases on the TiDB itself. And the data ingestion or the TP change are in real time. They happen in TiDB. So on the left-hand side, the data integration and the TP workloads happen directly in TiDB. So this will be this TiDB will be a real-time layer before the data entering the data warehouse or the data lake. So it will serve a purpose as the entrance of the offline layer, and provides you the real-time analytic services. After the data growing big, you might have some code data to be archived into the data warehouse. So you can use TiSpark. TiSpark is a component that's fully compatible with the Apache community version of Spark. So you can use all the Spark features just like community Spark version. And you can say that select some of the queries from TiDB and insert into your Hive database, just like those two simple queries, then you can have your data being archived into your data lake. And besides that, some of our users use the TiDB as the data serving layer because the Hadoop itself is not very good for data serving purpose. So after you compute your models, maybe labels or tags for your data training or your reporting, then you can have some of the database services to store those data. If you use something like a traditional database, then it might be very scalable. If you use like NoSQL, it does not provide you very complicated analytical services ability. So at this time, the TiDB, and again, becomes something very helpful. It is very both scalable and data queries, so you can have the TiSpark to write directly to the TiDB. So some of the custom stories. The Red Book of the Xiaohongshu is a famous name for the Chinese community, and it's a leading social media and e-commerce platform combined. They use their TiDB in multiple use cases, say that real-time reporting or the fraud detections. Before use TiDB, they have their stack of MySQL and MySQL cluster, and also the big data lake things. It's very costly to maintain, and it only provides the T+1. Say you need to you can only analyze the data for like yesterday, something like that. And then during the data moving, it's also very costly to check the consistency and to maintain the consistency. Um, and also, there's no ways for them before to process the data in real time. So after they use TiDB, they have like everything in real time, and also simplify their architecture. Some of the data does not need to go directly into the Hadoop data lake, and it's very easy to scale out. And they report after they apply the 4.0, they have a speed up even compared to the previous version of TiDB. They have like 4 to 10 times faster on the column store. The other name is the Beagle. Beagle is a very fast growing social network company and based in Singapore. And they provide like live services, live streaming services. They have a lot of users. And before they use TiDB, their business are like very hard to scale horizontally, and some complex queries cannot be served, and they have like a T+N they to process the data with ETL because they have like quite long ETL pipeline. And after they use TiDB, they use the TiDB for analytical services. We only know some of their use cases, say that analyze the network monitoring matrix or downstream storage for the big data system. But these might not be all the use cases they are currently using. The results they report are TiFlash improved the column engine called TiFlash improved the performance by 100 times, 100%, and core speed core time dropped by like 56%, and real time services save their time for like 1 day. So for them, the TiDB means the MySQL compatible. That's very important for them because previously some are technical stack are based on MySQL, and the strong consistency and high availability, and support a horizontal scale in and outs and real-time HTAP, and also easy to connect with the big data system with the TiSpark. Yeah, so that's all of the content for my presentation. Thank you.
Thank you so much for Sean for the brief introduction of HTAP. I know there are some questions from the audience, but we have limited time today, so we're gonna actually switch over to the next session directly. Sean, thank you so much for your presentation. Yeah. If you have any questions, feel free to leave the comment there, and also join the Slack community to ask any questions. We'll answer from there too.
Okay.
Okay. So Sean and Mengnan, so you can share your screen now, and we can start your session. So next session coming up is from Ninja One. If you haven't heard of them, they are the leading Southeast Asia logistic and courier service providers in this region. And we are very honored to have Sean here, their CTO and co-founder, and also Mengnan, the senior software engineer, to share with you their story on how to scaling their services. With that, switch over to you, Sean.
Hello, hi everyone. Thanks for being here today. So my name is Sean. I'm one of the co-founders of NinjaMan. So I'm the second Sean for today. So I really enjoyed Sean Ma's presentation today. So yeah, I'm very pleased to be able to host together with the TiDB folks, the TiDB user group. Really hoping that we have a lot of future sessions and get to know one another, share our problems. Yeah, I think lots of interesting things we can talk about. So maybe I can take a bit of time just to tell you guys who we are. We are a company that started off in Singapore about 6 years ago. And currently we are present in 6 countries in Southeast Asia. We deliver about upwards of 1.5 million parcels every single day. And yeah, we rely on huge amounts of technology to keep us running, optimize everything all the way from the customer experience to the operations and the after sales and everything, right? So yep, Singapore, and after about 10, 11 months operating in Singapore, we went into Malaysia, and right now 6 countries, 30 over 1,000 employees. So it's been very, very quick growth for us. What that means when you translate it to our tech is we've had to scale very, very quickly. So everything about our tech has always been about reliability, scalability. So that's my personal interest as well. Distributed systems and also database engineering. So these are some of our customers. Hopefully you guys are buying more stuff now and staying at home, keeping safe, and yeah, we'll deliver all the goods to you, make you happy. All right, so here's what we're going to talk about today. Firstly, we'll explore a little bit about how we are doing OLTP in NinjaVan. Then, what's next for us, right? What's our next generation database, both on the OLTP as well as the analytics side of things, right? Then I will hand it over to one of my senior platform engineers, Meng Nan. I'm really excited for his session as well. We'll talk about how we're starting to operate TiDB on Kubernetes and some of the pitfalls. All right. Okay, so yeah, we deliver millions of parcels every single day, and I just wanted to give you an idea of some numbers. We do in the scale of billion API requests. We ingest a huge amount of data every day, and we're built on a microservices architecture, right? So 100% of our system, our applications are deployed on top of Kubernetes, with the exception of our OLTP databases, which are still on VMs, right? But anyway, moving forth with times, we're even in the process of shifting those MySQL servers into Cube with the maturity of like the PVs, the PVCs. So yeah, and some of our databases are already in Cube. So yeah, no prizes for guessing. Most of our databases are on MySQL. Yeah, but before I talk a little bit about that, I just wanted to first of all give a shout out to all the NinjaVan engineers who are in this call, right? Thanks for supporting us, right? Yeah, we are an engineering company, so we're always hiring people all the time: database engineers, system architects, software engineers. Right, so yeah, this could be you. Okay, so on to NinjaVan's apps. So I said we have about 100 microservices in our system. We mainly rely on MySQL for OLTP storage, and generally our applications exhibit very high read-to-write ratios. Right, that's usually the case for most applications. Even more numbers. Now I'm just focusing on our databases. Now we maintain about 70 VMs, and that's excluding the MySQL instances that we've already pushed to Cube. We have about 100 plus schemas, and some of our tables, especially those that store huge amounts of audit trails, events, they are to the size of terabytes. Okay, so how do we run MySQL within the company? We actually use something known as Galera. I'm not sure if some of you guys have heard it, but if you have not, it's basically just MySQL binary together with a Galera plugin, right? You can Google what that is. But to just cut the long story short, it's kind of like a HA solution for MySQL, and it allows basically all the nodes in the cluster are all masters. So you can write to any of the nodes, and you can also read from all the nodes, right? So it's quite easily read scalable. So notice I say it's only read scalable, not really write scalable, because in Galera replication, basically all nodes are full replicas of one another. So a write on one node will result on a write on all nodes, right? So it doesn't have any sense to actually even load balance the writes. In fact, for us, as I'll show you later, we actually keep the writes on a single node, and we actually do read-write splitting across the other nodes. So here's a very simple diagram to explain how that works. So on the left side, you have the microservice, right? And on the right side, you have the Galera cluster. So in between, we're using something known as Proxy SQL. It's basically, again, another open source project that it's an SQL aware layer, and you can do a lot of cool stuff on it. You can define query rules. You can use it to ensure that you can use it to maintain high availability as well. So inside this diagram, you notice that I select the node as a virtual master. Now this is important because generally how it is, right, is when you have replication sometimes, and if replication is asynchronous, sometimes you will have delays going to the other nodes, right? So if you're doing anything that requires strict consistency, like account transactions, and you make a deduction, the writes will go to the virtual master. And if you want to have a consistent read, you should read from this virtual master as well, because you risk getting stale data if you read it from the other nodes. So this wrong computer. Yeah. So this is just an example of how we can achieve something like that using proxy SQL. So all we do, if you look at this rule here, we're inserting two rules. And the first rule over there is if we detect, sorry for all the slashes, that's just to escape the slashes and the asterisks. If we detect a comment in the query, ninja_critical read, we will route it to destination host group 10. Right? If it doesn't match, then it will go to host group 20. So what we do is the host group 10 is basically that single master server, and the host group 20 is the other two servers, right? Then on line 4, you can see we set the default host group to 10, which means that everything else, like your writes, updates, deletes, they just go to the host group number 10. Okay, so I did say that this solution is unfortunately not very write scalable, because every write is basically broadcasted. So actually, one of the use cases of proxy SQL is you can do some kind of sharding. There are a few kinds of sharding: user-based sharding, schema-based sharding, database sharding. So here I just talk about two types, right? The first one is schema-based sharding. What you can do is you can define multiple Galera clusters or MySQL instances, right? And based on which schema you are trying to select, update, insert from, it will write it to the appropriate host group. Okay, this is nice because when you have multiple clusters or MySQL servers, your application just connects to one server, right? Then the other one is database sharding, where you can actually within a single schema push your data to different shards, right? Based on, for us over here in this example, we have something called system ID. So just a bit of context, NinjaVan, we operate in 6 countries. So every single country we operate in has a system ID. So we can push Singapore data to one shard, Malaysian data, Indonesian data to other shards. So it's pretty configurable. But there are some drawbacks, of course. Anything more granular than schema-based sharding will require application level changes. And once you go to sharding, it's honestly very, very hard to go back, right? And once your data gets distributed across nodes, remember you can't do your joins anymore. So all these kind of so-called cross-shard joins need to be shifted to the app layer. Okay. What makes it even more complicated is we talked about the read-write rules just now. Now it needs to be added per shard, right? So per shard, per cluster, that kind of thing. And in general, as engineers, we are lazy because we are smart and we just want to take the simple way out of doing things. So we kind of held back on doing app layer sharding at this point of time. Adding on to that, we also started to experience some issues with Galera. So you know about DB operations. I think there are a lot of DBAs here. We are also quite lazy. So if we have to operate like 100, 200 clusters, it gets very tiring. Of course, you write a lot of automation to that, but generally we try to make our lives easier. And so we did that by grouping multiple schemas into Galera clusters to have lesser clusters, right? But what I said just now, right, it doesn't really work well because it's not write scalable. And the more schemas you put in there, you have higher write traffic, and one day you would have to start to split it. But thankfully with Galera, it's actually quite simple to do that, because creating a new node is as easy as just joining the cluster, and then something called a state snapshot transfer will occur, and you get a new node, and you can split it up almost with zero downtime, right? Worst thing is the intra-cluster communication due to the replication uses precious IOPS. And the last thing actually caused quite a number of issues for us. So the way Galera works is that in order for all the nodes to kind of like be up to date with one another, I remember you have the replication. If one of the nodes starts to not be able to catch up, that node will start to publish flow control packets. And basically that results in the whole cluster locking up. Basically the writes are blocked, right? So everyone is allowed to catch up. So this causes a lot of problems on the app layer, of course. Okay, so this one's quite interesting for us as well. So in the early days, actually, we didn't build like the big data engineering. We didn't have the Hadoop. And so we tried to do a very quick solution for BI. And, we have smart employees. So everyone knows SQL. And when I mean everyone, even the people inside the warehouse, even the driver supervisors, they know how to write some query to get something. So this was really the quickest way to do some kind of like BI without setting up any proper pipelines. Of course, today we have the pipelines all set up, right? And all we do is we use a front-end tool like Redash, and we query an array of backend slave databases that we just run the slave channels from the masters. The problem with this is that, when we design the schemas, the indexes there are optimized for our OLTP use cases, right? And a lot of cases when they do analytical styles, you start to have a lot of table scans, again IOPS, that slows the entire database down. So and everyone starts relying on it. Everyone knows that this is the place where you can just write queries and get your information. And then because it's slow, everyone is not able to get their information, right? One person can write a crappy table that does a table scan, or a crappy query that does a table scan on, say, 1 terabyte of data, and you're in big trouble, right? So this is what we kind of tried to do to solve that problem. So what we had was we had multiple masters as a source. So you can think of them as individual nodes from multiple Galera clusters. And we ran a multi-channel slave below that layer. So that's our tier 1 operational data store. So basically, we're just merging data from multiple sources into one database, right? And why we merge it is so that they can now do the relational joins across schemas, right? There's actually another solution to that using a federated data source in MySQL, but it's not good because it's an in-memory thing. And if you run an unindexed query on a federated source, you will actually crash the server due to the OOM. And now we have the ODS on the tier 1. We then have this so-called auto-scaling tier 2 slaves, which are just replicas of that tier 1 ODS. So this auto-scaling tier 2 is something that we did some automation to very quickly scale up if we need more read capacity. It's something like you do a snapshot on the disk, and then you bring it up, and that's quite quick. And then you set the replication on the bin log offset, and then you have a new node. So that we can bring up a new node within something like 30 minutes without much operations, just running a simple command, right? And then we have Redash talking to either a proxy SQL or a HA proxy, which load balances the queries, right? Now you see the ghost thing there. I'm not sure if any of you all have utilized this. I'm sure the DBAs know. It's something like the PT online schema change. Allows us to do the alters basically the DDLs online without blocking, because if you understand the MySQL thing, if you do a alter, it does a table copy, it blocks the writes, right? So these tools allow us to do it online. But we actually use Ghost because we wanted to ensure that the slaves don't lag behind too far, right? So what Ghost does is that it actually monitors all the way downstream how much lag you have from the source masters. And if there's too much lag, the online the schema change, basically the table copies will slow down. Okay. And the problem with this is that if it's lagging too much and new data is being fed into the masters all the time, the Ghost process might actually not even end at all. So basically, you cannot complete the table alter. So that's actually still a problem with us, and we actually solve it by just rebuilding the slaves when the alters finish. So yes, sorry, wrong computer again. Yeah, so one interesting thing we did was we also tried to vertically scale the MySQL storage by using local SSDs instead of the persistence disk, because we get huge amounts of IOPS and throughput when you use local SSDs. The idea is that local SSDs are actually on instant storage in the cloud versus persistent disk, which is communicating through fiber channels in the data center. So you get huge amounts of performance gains, but you know the problem with that, if you guys have worked with local SSDs, is that in the cloud, when you deploy a VM, you stop the VM and you start again, actually you might not get the same physical machine inside the data center, which means that your data is actually lost the moment you do a reboot, right? So that's quite risky, but for us it was okay because anyway, if it rebooted, it will just be kicked out of the cluster. We'll create a new one, and then it will just join back the proxy SQL cluster again. Yeah. Okay, so knowing the problems we have, I mean, not just this use case, right? But in terms of our OLTP, our volumes are growing. You've seen how we've grown 6 years from just tens of parcels a day to millions of parcels a day. Our write traffic is growing much faster. We're having a lot more schemas. We need an easy way to operate the database, right? So it's time to look for a change, right? What's out there? Should we go NoSQL? Should we go new SQL? What should we do, right? So here are some of the requirements that we look at. I guess one of the important ones for us is that it should be kind of like MySQL compatible because we are lazy. We don't really want to make so much changes to our code. So ideally, it should be as compatible as possible, right? So it should support all the standard SQL grammars. Now, easy operations is as critical to us because if you want to scale up, increase the number of nodes, we want to just declaratively say, okay, we want 10, and then that should happen as much as possible, as easy as possible. We want to be able to do non-blocking DDLs, out of the box if the solution supports it. Read-write scalable, I think that's needless to say. Highly available, we need to be 24/7. CDC, it has to support CDC because CDC is quite core to our use case. We use CDC for data ingestions into our data lake in Parquet. We use CDC to index searchable data in Elasticsearch, and we use CDC for updating our caches as well. So that's critical. The other one is monitoring. We are very, very data driven. We want to know when something's going wrong. And so that we can respond to it, because availability, performance, that's very critical to us, right? And lastly, I said before, we are trying to push everything to Kubernetes. So so we can be lazier. Okay, so what did we explore? A few things: Vitess, CockroachDB, and of course TiDB. We have gone through all this, and so in the end, we felt that for a solution like Vitess, if you have already been doing application level sharding, that makes a lot of sense, right? Luckily for us, we have not yet. So basically, it gave us a bit more choice. Do we want to go that way and adopt Vitess, or do we want to just be lazy and use something like TiDB? So yeah, please let me hand over the time to Mengnan, and he will take this to the next step.
Yep. Okay. Thank you, guys. My name is Mengnan. Okay. I think I will just dive into the topic directly. So after Sean's introduction, I hope you guys are all very thrilled to see like how TiDB really works together with Kubernetes. So let's begin. Okay. So before I jump into the TiDB part, I want to take a little bit time to like introduce what is a control loop in the Kubernetes for the stateless applications. Okay, so basically, if you have an app running in Kubernetes, you mostly will like deal with some of the resources like deployments, config map, and service. Okay, for deployments, it's managing your replicas, and for config map is managing your configuration, and service is to make your application accessible by others. Okay. And let's see if you want to have more replicas for your application to achieve the HA, so the Kubernetes can bring you 2 more pods, let's see. Okay, and of course there is failure recovery. So if one of the application is down, Kubernetes will replace it with a new one. Okay, so all of this magic that Kubernetes is doing is based on something called control loop, which you can also call it reconciliation loop. They are the same thing. Okay, so this loop is an infinite loop that running on the Kubernetes controllers. So what it does is like it's watching the current state and comparing it with the desired state. And if it notices any difference, it will try to make adjustment and try to meet the desired state. Okay, so all of this sounds pretty seamless and it's quite smooth. Okay, but the problem is it's only for the stateless applications. But the question is what makes the stateful application different? Okay. And here we got some characteristics that only exist on the stateful applications. Okay, so first one is all the replicas for the stateful apps are different and they have their own state and identity. Okay, it's quite straightforward. It means like if you have a cluster, let's see a cluster of MySQL, and all of the MySQL instances might actually contain different data. So you can't really just replace one with another one. Okay. And the second point is the processes are different for each application. Here I got some examples, let's see, for Elasticsearch or Kafka or even MySQL. So all of these you need to operate and maintain differently. There is no universal procedure for all of these applications. Okay, so it means it could be a heavy burden if you're running a lot of this. Okay. And the last point is about the order matters. Okay, especially for the distributed systems, you need to follow certain sequence when you boot up or like bring down some nodes. You can't just randomly bring up or down any of the members in the cluster. Okay, so based on all of these difficulties we have, so here I introduce the TiDB operators. Okay, so operator pattern is actually similar to what Kubernetes controllers is doing. So here is mainly 2 parts. So firstly, for the operator, you need to deploy the TiDB operator, and it's also running a reconciliation loop as I introduced before. Okay, and the other thing is about the custom resource. For the customer resource, in our scenario, it will be the TiDB cluster. Okay, for the TiDB cluster, once you deploy and you make any changes, the operator will take note of it, and then it will make adjustment accordingly and make your current state meet the desired state. Okay. I think that should be enough talk. So I will show you guys some example here. Okay, so firstly, it's about the scale up. Okay, so let's say if we only have one TiDB node and we want to scale up to 3, all you need to do is change the replica number as I showed just now. And if you go back to this, you will see there is already 3 TiDB nodes running. Okay, and the second example I'm going to show is about backup to GCS. Okay, okay, so I think we need to wait for a bit for this GIF to replay. Okay, so basically it will start as a YAML file. Okay, you need to prepare the YAML to define the backup. Okay, and then you need to apply this YAML in your Kubernetes. And after you apply this, you should be able to see that the TiDB operator actually pick it up and the status is updating while the backup is ongoing. And after this is completed, you can see it's already on the GCS. Okay. And you can see all those operations are quite easy, quite smooth. And I think I'm proud to see that NinjaVan and TiDB gonna end up marrying and then live happily ever after. And the end of the story, or not. Okay, so sorry, I lied. So the fairy tales doesn't really exist. So there are still some pitfalls I need to share with you guys. Okay. So first thing is about like be careful when using the local SSD. Sean's already talked about like why we choose local SSD, right? If you take a look of this diagram from a GCP, you can see there is really a huge performance gap between the local SSD and the regional SSD. Okay, so it gives us like the motivation to really try to run our TiDB cluster on the local SSD. Okay, but before you jump into that, I have some tips for you guys. So first one is, please, if you are running your Kubernetes on the cloud, let's see AWS or GCP, please disable your auto repair or auto upgrade. Okay, the reason behind it is just as what Sean said. If when the auto repair or auto upgrade your node, it actually could be replaced by some other machine. So you will just lose your data because your SSD is tied on the machine. Okay. And the second point is about the local volume provisioner. So this thing is what we use to expose the local SSD in the Kubernetes. But as we mentioned before, both of your, so the local SSD is actually a daemon set running on the Kubernetes. So both of these daemon set and your like machine could restart at any time. So you don't want to like accidentally reformat your disk and lose your data. Okay. And the third point is, of course, about the backups and have a standby cluster if possible. So even the worst case happens, you still have a way to recover. Okay. And the second thing is about the MySQL compatibility. So first of all, like I know that TiDB really put like tremendous effort to make it compatible as possible to MySQL. But there's still some small point that could trouble you. Okay, so first one is about the enum elements. Okay, so TiDB doesn't allow you to modify it except you just appending. Okay, so the solution for this is we will just do append only. So we need to avoid like shifting the elements or deleting or updating it. Okay, and actually the second point is in general you should try to avoid use enum type because you try to hide some business logic in the database layer, which might make your application less extendable. Okay. And the second problem you might be facing is changing some column types. Okay, so let's say you change the date to timestamp or vice versa, or you want to change the precision of the decimals. So like all of these, actually, you can't really do it on TiDB. Okay, so you can only recreate the columns instead of altering it. And here comes the second point, and the second is always the best. Okay, so you should establish a schema review workflow. Okay, so we believe with the proper like data schema design and review with your like infrastructure team or with your DBA, it actually should cut like most of the unnecessary column type changes after your schema is already created. Okay, and the next one is about the character set and collation. Okay, so I think most of you should be familiar that MySQL's general collection and the main difference between these two collections is like the MySQL one is actually case insensitive. And like when we first deploy our first cluster, we actually have some problems because like the people who write the query might not really follow the case sensitivity in your database. So you end up have different query result. Okay. But the thing you need to notice that if you want to enable the general collections, you actually have to enable it at the very beginning, at the initialization of your cluster. If you miss that time, you cannot enable it again. Okay, so this is something that actually could like make some troubles, and I believe the team is already working on some solutions for it. Okay. And the last one is about preventing TiDB from OEM. Okay, as engineers, I suppose we all hate OEMs. Okay, but it's kind of inevitable in a life. So firstly, there is a memory quota per query. Okay, and the second is if the OEM really happens, you can choose to cancel the query. Okay, and the third one is you also can use the temporary storage, so it will spill the data to the disk, so it won't really like take too much memory. Okay. But the thing is, even you've done all above it, the OM still could happen. Okay. So the main reason could be the memory quota is actually per query. So if you have a lot of queries and all of them taking a lot of memories, then it means you still could OM. Okay. So the advice is keep an eye on your queries. Okay. So after all the good and the bad, so I want to talk about the future with TiDB. Okay, and so the first challenge is about change of mindset. Okay, so this sounds like a very big topic, but I just want to give you guys one example about it. Okay, so the first is like, do you know, like in TiDB, you should avoid using auto increment primary key if possible. Okay, so this at the first glance is very controversial, I would say, because like if you are familiar with MySQL, you would know like it's really recommended to have auto increment primary key. Okay, so at first we're gonna take a look like why MySQL in favor of it. Okay. So for you have a diagram here. So this is like an oversimplified version of like how the cluster index looks like in a MySQL InnoDB. Okay, so the cluster index, it just means the data is sitting together with the index. Okay, so and if you see all the leaves, these are called page. So the page is just the basic storage unit in MySQL to store their database files. Okay, and so let's take a look what happens with auto increment primary key. So all you need to do is you have a lot of pages and you just need to appending. Okay, and if there is not enough space, you're gonna have a new page and you keep appending, and it's quite cheap because it's all sequential. Okay, but if you don't have one, and let's say your data will randomly insert into any of the pages, then you will end up have like data movement, and you might have to split your pages, and you might have the memory fragmentation because MySQL will try to read one page at a time to utilize the memory more efficient. If your data is going anywhere, then MySQL need to keep load and offload the pages, so it's really inefficient. Okay, and after that, so we're gonna show you like why TiDB doesn't need that. Okay, so firstly, for the auto increment primary key, so if you do that on TiDB, so mostly all the data will end up to one of the region on one of the TiKV node. Okay, so which means the traffic is pretty much centralized. Okay, but on the right, if you have like let's say a random primary key, and then it actually can distribute the writes to like in your cluster and to different regions, and it will end up a better performance and a higher throughput for sure. Okay, so this is all because of the distributed nature of the TiDB, make it like very different. So the change of mindset is actually quite needed in this. Okay. And the second point is about support our CDC scenarios. Okay, so we mainly have two scenarios. So first is about hard delete. So hard delete is just I want to delete from my database and the data lake. Okay. And for archiving, I just want to delete from my database to release some space, but in the data lake, I still want to keep it. Okay. And the reason, okay, so the approach we do this is we actually rely on the comment in a query. So if you see the example, we do like say delete from orders, and then we have a comment called for archiving. Okay, then like on the consumer side, we will know that we shouldn't delete it from the data lake because it's just for archiving. Okay, and here is our current structure. We have a bunch of MySQL instances, and we use something called Maxwell. So this thing will just as a slave of the MySQL instance, and it will forward the raw query to the Kafka, including other informations. Okay, and then on the other side, the data lake will consume the messages. Okay, and the story is on TiDB. We actually like don't have something like Maxwell, and the problem is it cannot forward the raw query, which means we will lose these comments in the query. And here is the solution that we can think of for now. Okay, so instead of replacing the MySQL at here directly, we actually make the TiDB and the TiCDC. Okay, the TiCDC you can consider is similar as Maxwell, Okay, so it will also listen to the TiDB's changes, but this thing cannot forward the row query. Okay, so the MySQL will still listen to the events and rely on Maxwell to forward the row query. Okay, so like all the delete action will actually happen on MySQL, so we still can keep this for archiving comments. And okay, here comes the last slides. So of course, we want the minimal downtime migration, consider we delivering like millions of parcels a day. Okay, so here is how we plan to do it. Okay, so firstly, you have the very basic setup of your application in your Kubernetes, and you have a MySQL, which is running on VM. Okay. And the first thing you want to do is, of course, deploy the TiDB. And after you've done that, you need to sync the data to TiDB. Okay, so here, TiDB actually have two tools. So first is DM, stand for data migration. And second is TiDB Lightning. Okay, so if you guys interested, you can Google it and take a look at the documentation. So, and after the data is in sync with MySQL, and the next step would be cut the connection to MySQL, and then we point to TiDB. Okay, now the TiDB is already serving the application, but we still have one last step, which is using the TiCDC to sync the data back to MySQL. Okay, so this is mostly for like it's served like as a last resort. So let's see if the TiDB has any problems and we have to roll back to MySQL, we still have the fresh data on MySQL. Okay, and I think that's all from me. So I think we probably still have time for Q&A. So we are glad to take any questions if you guys have.
Yeah, so
Thank you.
thank you so much for the session from Sean and Mengnan. So we do have a 10 minutes session to really answer the questions from the audience. Feel free to ask any questions in the chat and in the Q&A. So coming up, we will have another session for Fireside Chat, where we will have a Karen from PayPay, Changjun from Grab, Sean from NinjaOne, and Ed from PingCap to have a Fireside Chat. So we already have a first question coming up. The first question, the audience is asking, what's the challenge you guys have been facing when you migrate to TiDB? I know you already talked about a lot of challenges already. Anything else you want to highlight? If not, we can skip this question. But anyway, please, if you have any answers on this.
I will mute myself.
Sean or Monan, do you have any?
Yeah, sure. I think I can take this. I think we did talk about quite a number of challenges there. For us, really, it comes back to the requirements, right? What kind of tech can we move to that's a bit more scalable? That's more scalable. That we don't have to change our entire code base, but it's quite apparent that it's not just a drop in, right? You don't expect to just drop it in and then suddenly it works. So of course we have quite some amount of work to do. Even on the migration, a lot of our ops, if you look at our business, is 24/7, right? How can we do this migration without missing a heartbeat? Because a lot of companies, they are quite lucky that 3 a.m., 4 a.m. Is a good time where you can do like 10 minutes downtime. But at our scale, we cannot even afford that 10 minutes of downtime. Maybe we have to bring it down to like 1 minute of downtime, right? So that's another challenge. And of course, if we are allowed to have like 1 hour downtime, we don't have to spend so much engineering effort to go and figure out all this like double writing and all that stuff. Yeah. Besides that, I guess figuring out doing a lot of testing, load testing. The tech is still for us relatively new. Not a lot of experienced people working on it, which is precisely why we really appreciate such a user group. We can share some problems. Yeah.
Cool. Thank you, Sean. So we have another question from another Sean. The question is like, why don't you use CEPH, Zephyr, to manage storage?
Do you want to take this, or you want me to take this?
Yeah, I think
I take it. Okay, yeah. Ceph. I mean, we've looked at Ceph before a few years back. what was it? If I remember correctly, we didn't take it because for that little problem that we were looking at, the one where we have IOPS. So Ceph is some kind of a distributed storage layer, right? And you can basically increase your IOPS at a more cost-effective way. I guess if you deploy it across persistence, you won't lose the data on restarts. But for our use case, we didn't want to adopt something new, right? And generally for us, we always take the idea of keep it as simple as possible, which is also probably the reason why we actually prefer something like TiDB, right? But specifically on Ceph, actually for local SSD, that our solution we're using is actually much more performant and much more easier to manage. And actually local SSD is cheaper than persistence disk as well. Yeah.
Cool. So we have another question coming up. So looking backward, what do you wish you had or knew it beforehand?
What do we wish we knew?
I think it's more like talking about using TiDB.
Yeah, I mean, if we knew TiDB was around, we can start earlier. No, I don't know really. A lot of our challenges happen because we are a company that scaled up very, very quickly. And our tech team has to react very quickly to it, right? Especially on performance and reliability. There are a lot of unknowns in our business, like for example, COVID, when it comes, it's also a challenge for us to make sure that our systems can be able to deal with that load, right? Meng Na, do you have anything to add? Okay, yeah. I see one more question.
Yeah, so there's the one last question. If you have any more, please add in here. The last question is, how do you handle the stability issues of Kubernetes? I have been hearing a lot of these kind of questions from the community and from different chat groups. Pretty good one, I think. If you have any answers to that, it will be good.
Okay, I will come from my point of view, then I'll see what Meng Nan has to say about that. Actually, for us, Kubernetes has been working rather well, and the whole idea of Kubernetes is also you design your architecture in such a way that you expect everything to fail, right? So things like making sure that your master nodes are across zones, you have nodes from multiple AZs as well. Your applications, of course, have to be deployed in more than 2s, more than 3s, that kind of thing. So yeah, you must expect failure. Yeah, basically that's what I have to say. Meng Nan. Yeah. So nothing else to add from Meng Nan.
Yeah, so actually just now, because our Shang Ma already went offline, he has other meetings to attend, but he does has another comment, like PingApp has been working on S3 already, so hopefully can resolve some of the concerns from your side. Okay, I just wait one more second. If there's no more questions from the audience, we can kick off the fireside chat. So I already see everyone is here already. We can wait for 1 second. I see Karen coming online. Sean is here. Ed is here. Cool. Changjun, where's Changjun?
I'm here. CG.
Okay.
Yeah.
Cool. Nice. So we don't have any more questions. So let me share my screen. Yeah, so the last session, but really a very good one, I've been really looking forward to this fireside chat, is the topic. I think it's an interesting topic in the way, like if last year at this time, when you want me to kick off this fireside chat, I will ask, the China's Singles Day, Indonesia's Habalonen's Day, or US Black Friday has been really kicking in for all the consumers. Things has been changing from online to offline to online, online to offline. And the scaling of the infrastructure has been really an issue for many tech teams. But for this year, at this time, for our first ever TUG APAC event, COVID-19 is still there. And even though Asia Pacific, things has been cooling down a little bit, but the US and EMEA still suffer. But ironically, all the consumer behavior has been changing from really offline to online. Some of the industry has been suffer, but there are industries have been really seeing a dramatic growth for the past few months. And I hear a lot of people from different industries in terms of the technical leaders and business leaders. They think a very dramatic digital transformation for the past few months, which has been really accelerated the whole thing for how they adopt internet, how they use the technology to bring the consumers better experience, much faster delivery speed, and a better user experience in terms of when they use the service, right? And today's session, I think we are very honored to have Sean from Ninja One, Karen from PayPay. PayPay, if you haven't heard of them, PayPay is that leading QR payment company in Japan. Later on, Karen gonna introduce you more about that. And we also have Changjun from Grab, and last but not least, our CTO from PingCap in this fireside chat to talk about the hypergrowth business challenges from architecture, from technical perspective, what they are, how they have been experienced, and how do these see the solutions for those kind of challenges. With that, I really want to kick off this fireside chat, and to get it started, maybe we can start to introduce yourself. We can start from Karen.
Hello, can you hear me?
Yep.
Yeah. Okay. So first of all, thank you so much, Neil and PingCap and everyone else for having me in here. I mean, it's really great to share a panel with all of you. So I'm Karan Thanvi, and I'm working at PayPay, maintaining the microservice infrastructure platform, and also taking care of all the TiDB migrations and all the operations related to TiDB maintenance and upgrades and all the lifecycle part. About PayPay, so as Neil shortly said, that PayPay is currently the leading mobile payments company in Japan. We offer a variety of payment methods through your smartphone, such as QR code-based payments or barcode-based payments. But apart from these, we even have extended our services to different sectors, such as we have integrated with food delivering companies such as Uber Eats, even with e-commerce platforms with Yahoo Japan, and even taxi bookings and all other aspects where you need to make a payment. You can use PayPay. The goal that we hold is basically to promote cashless society in Japan. And we are still working harder to make sure that we can promote cashless even more. So again, like, thank you so much for having me, and I'm really looking forward for a good talk with all of you.
Yeah. So next one, Kangjin, can you introduce yourself?
Yes. Hello, guys. I'm Changjun. I work at Grab, mainly responsible for construction of RDS and automation platform. I'm honored to participate in TUG. Yeah, thanks.
Nice. Okay, Ed, your time.
Okay, hello everyone, this is Ed. I'm the co-founder of PingCap and TiDB, so I'm really proud to be here to chat with you guys, and I'm also really proud of we building such a great tools helping users just like you guys. Thank you. Yeah, really looking forward to talking with you guys.
Yeah, nice. So I think one thing I forgot to mention on this panel, except me and Ed, so three of them are the co-leaders and leaders of the TUG APAC. It's such an honor to have you all. Okay, so I think we talk about the hypergrowth challenges, right? Karen already introduced the business they are in. I believe for the past few months, your business has been really growing quite fast. What kind of scenarios you guys have been seeing for the past few months in terms of the growth areas? Can you share with us?
Yeah. So for PayPay, we are very new company and a very new service. We have completed 2 years this month. So, but looking at the time we have been in market, the growth that we have achieved is quite huge. So we have more than 30 million users already. And thus we have a lot of daily traffic, daily payment requests that we have to serve. Also, because we support a lot of payment methods and even we have a lot of integrations, the core payment service that we have has become a very write heavy service. I think this is all because of the hyper growth that we are getting. And because of services becoming write heavy, the databases that we had for our core payment services, they started to become the major bottleneck when it came to the performance. And at this time, we realized that we need a solution which basically can allow us to scale out the database as well in more distributed fashion, so that we can guarantee better SLAs and even guarantee a good performance. So the major scenarios that we are facing is actually how to support all the increasing traffic with a very strict SLA because we are in a payment industry right now. Also provided that we have the performance intact. So I think like this is one reason why TiDB is probably the ideal solution for us.
Nice. Sean, how about you? I think you shared the technical selection and all those, but from the growth area perspective, what kind of growth have you seen in the past few months? And what are they, and how have you seen the things happening?
So I think it's probably quite common across a lot of us companies in the online e-commerce business sector, PayPay also in the payments. Everyone is starting to go online. So the rate of growth is incredible. I mean, I showed some numbers just now about our company, right? And we've grown very, very quickly in just 6 years. But one, I mean, unexpected thing that happened, the whole COVID. Actually, I was just in another panel just now, and I heard one of the panelists say that COVID has actually kind of like just brought the future earlier by like 3 to 5 years. And I think that's quite accurate to say. We've seen more people starting to look at, buying things online, making digital payments, no longer as a convenience, but it's now a necessity, right? And so the IT in the tech industry is extremely right now. So in terms of how that changes for us, our data ingestion has been going up, right? I share the same sentiments. Our write traffic is increasing. We need to figure a way to relook at how we are building out our OLTP system so that 1 year, 2 years from now, we don't have to suffer and say that, yep, our solution doesn't scale. So yeah, I think now is a fantastic period for all of us, and we've got to invest some effort right into the storage side of things, which we can share a little bit more later on.
Sure. Cool. Yeah, I think it's really, I mean, it's the first time I actually have a same place with Ed here to talk about TiDB and PingCap. So to myself, actually, I'm very curious, like as a representative of HTAP. Some of the audience just know what is HTAP. It's pretty much a hybrid transaction and analytical processing technology. So TiDB has been really developing for the past 5 years. what drove you and the team to turn this new technology into an entrepreneur project and to have this one to the developer community?
Okay. Well, and yeah, you know, before PingCap, I worked for a fast-growing internet company in China called Wando Labs, and it is a typical internet company. It's like their business is like the app store for the Android platform. So at that time I was working for the storage infrastructure team in charge of the MySQL cluster. And I would say at that time we were using a lot of MySQL, a large sharded MySQL cluster, and it has a lot of problems like scale out is really painful, and the resharding really painful, and also you have to get up a lot of features like relational database, like transaction, like complex query, join, group by, something like that. And so at the time, 5 years, it is like 5 years ago, 6 years ago, and that we want to build a new database that users can just use like a single MySQL, but that scales. And so that's the you can use the great features from the traditional database like Google Days, and don't have to worry about the scalability. So that's the beginning of TiDB and PingCap, and me, Max, our CEO, Dylan, and our another co-founder, we all worked in Wando Labs, and we quit our jobs and we started a startup to. We think it will have a bright future of building such system before because there was no
Yeah, I think Ed has some audio issues.
So and then, as you know, the TiDB become more and more popular, and we found that we somehow become a bigger and better MySQL, whether it was replacing MySQL or as a MySQL replication, MySQL backup. And some users just found out, realized, why not just use TiDB like OLAP database? Because all our data is stored inside TiDB, and it can scale out well. So so the user don't want to migrate the data from TiDB to another data warehouse, something like that, because TiDB's SQL support is so well. So and then we decide and more users trying to do that. So we decide to make our OLAP feature better to meet the needs of this kind of users. So that's the idea of TiSpark and the TiFlash. So that means the whole TiDB project is the beginning is the MySQL sharding replacement, and then become the HTAP system. But I would say the idea and the implementation of TiFlash is really smart and elegant. I'm really proud of it. So this is the little story about TiDB and PingCap. Okay.
Nice. Thank you so much for sharing that one to the audience. So I think from the vendor perspective, you have been really talking to a lot of industry players, technologists, the leaders in the engineering space. I think you may have some of the first-hand information, like what are the hypergrowth industry so far you have been seeing in the past few months. That will be some interesting insight to share, I feel. And also we talk about this hypergrowth, right?
Yeah. You asking me or?
You add.
Yeah, sure. And speaking of the hyper growth, I would say from my personal perspective, all of our users are getting bigger and bigger, not just one or a few industries. Especially since we now live in a world where all industries are being digitally transformed. We put everything online, and that counts a lot of data. So also, COVID-19 has accelerated this process. So, but I would say some of the industries, something like public service oriented, like payments, like e-commerce, something like this, like the infrastructure of modern business, just like PayPay and just like Shopee. It is, I think that this kind of business will become the infrastructure of the modern world. So I think that this kind of industries are growing faster than others nowadays. But in the long term, I think every industries will become, have big data and being digitally transformed. Yeah, that's my point of view. Just, yeah, it's not one or two industries, it's all over the world.
Yeah. Okay. We already talked about the industries like currently having a hypergrowth. So from the technology perspective, we are all technologists. Changjun, what are the considerations and procedures for you and your technical team when you really start to look into new technologies and the products? Can you share with us?
Okay. The first, we will take the business type and the current issue into the consideration. For example, if data size keep increasing and frequent database sharding or split is required, then we will check the technologies in this direction and look for a suitable product in the direction, such as a distributed database, like the PinCap, the TiDB. Yeah, countries, there are a number. Sorry, the telephone. Countries, there are a number of the popular open source and business database. When we evaluate products, we will investigate its stabilities, high availabilities, and whether it can keep solving the privacy issue. Quickly. The most important thing is to check its performance in a real production environment. We can research its current applications example in technologies companies and how it performant. Yeah, thanks.
Yeah. How about Karen, from your perspective for PayPay?
Okay, for us, so I mean, I've been focusing on this point a lot that because we being a payments company, for us, even choosing a technology stack or a new product for any critical system, it's very challenging because we have to guarantee a very high SLA. And because of this, what we do is we put a major focus on fault tolerance and performance of any product or any technology stack that we will choose. And also now, because it's about database, we had to take care of all the performances in case of huge volume of data, because we could see and we could predict the data volume that we have is going to be is increasing even more. So what we do is when we have to choose a product, we during the POC phase, we do a lot of disaster drills or disaster recovery drills to verify the fault tolerance and availability of the solution in case of different component failures. So what we do is we introduce a lot of troubles to the product during the POCs. We use a lot of tools which can help us simulate some behaviors. And we see that even after partial failures or some component failures, if we get significant performance from the product, then it's a yes. Otherwise, it's very difficult for us to move ahead with that technology. Apart from that, from the performance perspective, we also have to do a lot of load tests in the POC phase itself, and not with the current load that we have, but we actually test it with a forecasted load, which we have forecasted for future because we have to plan it for a longer run as migrations are costly. So what we actually did the same for TiDB as well. And as we have TiDB running in production, so I can say that all these factors were satisfactory. One more point I would like to add about consideration is that apart from all the technologies, such as the product being distributed, being highly scalable and all, we also have to take care of all the stakeholders which are involved in the process or which are involved in the product or in Pepe, because we have a lot of integrations and the business is growing. So even business members need to agree. So for that, we also want the product that we choose to have some production experience or some shown production experience already. And when we looked at TiDB, we saw a lot of major fintech companies in China were also using TiDB for probably a longer period. So then it was very easy for us to convince other stakeholders as well. So that way we actually did it.
Understood. From the technical, major technical challenge perspective, I think we talk about hypergrowth business, right? But you know, when things start to scale, things start to going down, right? So I saw a lot of issues happening in some of the cloud providers recently in Japan, which is horrible. But it is a fact, right? Because we can't expect the future. We can only prepare for that. From that perspective, Sean, how do you really make sure the system is scalable when it comes to the technical challenges?
Yeah. So because actually maybe coming from our point of view, our business is actually quite seasonal, right? And it's all because of like what in China, the double Singles Day. And then now every month we also have some kind of a sale, you know, 11, 11, 12, 12, 10, 10. Soon every month we have. So the challenge with that is also because you don't want to, in terms of like your infrastructure, your platforms, we don't just throw money at running a lot of servers and keep them running. So for us, cost control is quite important as well, right? So we invest a lot in stuff like architectures that use things like preemptible instances, or if you're familiar with the AWS, like spot instances, which is cheaper, but it can be removed from you in 24 hours, right? The whole basis of it is that you have to design a very highly available infrastructure, right? And again, with a what you call hyper growth business, it also means that your engineering teams have to react very, very quickly to new products and services that the business is all trying to roll out. So a lot of how we architect our stuff, microservices, you know, investing a lot in the platforms, containerizing everything so that on the operations side, things are easy. We can sleep a lot. We can sleep at night. We're also pushing out things like site reliability engineering practices, where we really take a look at reliability. We really measure the numbers, make sure that our SLOs, SLIs, SLAs are kept in check, right? And see, when your team gets larger and larger, generally it gets harder and harder to ensure good code quality, because you start to have to put a lot of processes in place, like unit test coverage, quality gates, right? Now if I just fast forward to the technical side of things, in general, at Ninja we do take a very huge focus in investing in distributed systems, right? But really, the database layer is always the hardest layer to scale. But we are also very careful that we start seeing some slowdowns on, say, our MySQL layers, right? Single server. Okay, we do read, write, split, right? But a lot of times we also forget that should we then suddenly invest into going into the next distributed database when we even haven't settled like the more basic things like, caching, ensuring that we are architecting our systems correctly, right? The next thing is that when for a scalable system, and when we're starting to introduce a lot of new technology, when the company gets bigger and bigger, every single change you do starts to affect many people, right? In the early days, there wasn't really much of a process. You see a problem, you make a code change, you push it, no PR, no code review, you just deploy to production. That's fine. But today, there is so much things we have to do to ensure that every single little thing we do does not bring down some component, because there can be cascading failures, right? So even implementation of TiDB, there were so many things we had to look at. Our CDC, how does it affect our data engineering teams, and so on and so forth, right? But in general, scalable and reliability, make sure that we invest in the right tech that can scale up horizontally. Reliability wise, we're doing a lot of things around chaos engineering, which is, I mean, again, shout out to the PingCap guys. We really love chaos mesh. It's something that we are starting to utilize at NinjaVan as well.
Oh, nice to know that. I saw Ed has been nodding his head quite a few times. Ed, do you have anything to add in?
Yes. Actually, I really totally agree with the saying about the high availability stuff, and we have to build system on the high availability infrastructure. Especially like TiDB, even though TiDB is an infrastructure software, but I'm thinking building the next generation TiDB on top of the cloud infrastructure like S3. Maybe we can put a storage infra based on S3 and use the local disk as just as a cache layer. So what makes me thinking this way is that I noticed that the S3 provides super high availability on cloud, like 99.99999. And so you cannot build it is the infrastructure provided by the cloud vendors. So that means it is like rock solid. So I really agree with you saying about the part that we have to build the service on the solid infrastructure. Yeah. So we're thinking about that.
Very good add-on. How about Karen? I think we have been working with your team for quite a few months. What do you feel about that question in terms of scalability of the system? You need to make sure it's ready for any hypergrowths.
Yes. So as you ask, like the technical challenge and then the scalability problem or the concern. So I think that's the major concern that we always have right now. How do we scale the system within time? Uh, because what happens is that as Pepe, we also do a lot of promotional campaigns and a lot of different activities to have more users and make sure that the users are intact. The system needs to be scaled in a very random fashion or in a very short period of time. So that's a big thing. We always need to figure out what is the limit of the system that we currently have. And I think as Sean just mentioned, we also cannot throw money on it, because again, infrastructure gets very costly, and then we have to, if the resources are way over the limit, then we have to pay a lot of money. So what we do is for all these situations, we actually conduct regular performance testing in our infrastructure. And we don't only test the databases or maybe Kubernetes clusters or the infrastructure, but we also utilize all the microservices that we have, and we use them to achieve more and more QPS or TPS, and figure out where we are getting a bottleneck. And every while when we do a performance test, we figure out that some component is now showing some bottleneck, and then we have to tune it. So it's not only database that we tune, it's also our microservices or the application code, or even a small bit in the code that we change to make sure that when we scale the specific component, be it database or application, we should not face any performance degradation. Uh, I think that's pretty much we do for scalability. yeah, the regular performance tests, I would say in short.
Nice. So in terms of the Changjun, from the data architecture perspective, what are the new technologies currently the company has been really adopting? What's the factors you consider for the data architecture selection from your perspective? Yeah.
Sounds okay. The actually current the data architecture is quite seamless in most international companies. For example, when cache layer is added to upstream, RDS used for data storage, and downstream will use the big data read storage. If there is exciting data architectures which can integrate the OLAP and part of downstream RTP, it will reduce the complexity and the length of the whole chain. With the short chain, it can help to reduce the possibilities of issue happening. Moreover, it can also help to reduce operation and maintenance cost. Of course, the most important things to choose the suitable database based on our scenario. Therefore, a distributed is an important area where DBA should pay attention to. Yeah, sounds.
Yeah. So I think just now we talk about the challenges for scalabilities. I think exactly the same thing we should consider for the data architecture. So that's where I have to ask Sean again, what's your criteria for the new data technology and data architectures when you're trying to adopt the new technologies?
Yeah, I think the criteria is like what I mentioned just now in the previous presentation. I think those I already mentioned. But if we are thinking about data architecture, I maybe look at it bigger picture. Besides the OLTP stuff, maybe we can talk about the OLAP workload.
Sure.
So, I mean, traditionally now we are starting to move towards more real time. So instead of like batch ETLs, Meng Nan talked about how we have to shift our Maxwell ingestion parquet into TiCDC. So we want to try to get as much as possible real time ingestion to our data lakes or near real time, right? We are also looking at maybe how do we reduce our time spent on operations, right? So when we first started doing stuff like Spark, Hive with Hadoop, right? We used to start off like maintaining our own Hadoop clusters, but then we start utilizing services like Dataproc in GCP, which is basically just manage Hadoop. Same concept. When we started Cube, we were just running Cube, bootstrapping the Cube cluster with Cube ADM onto EC2 or Compute. But now we move towards GKE, right? So the engineers have less to worry about. But what are we looking at? I mean, right now with HTAP is actually quite interesting, and we want to see how we can probably harness the power of TiFlash. I shared a little bit just now in the presentation about that BI use case. Actually, that's what we're trying to see whether TiDB and TiFlash works well for us. But right now we are already doing a lot of our data processing workloads on Spark, and we've also shifted Spark onto K8s, which now is still experimental, right? But that's what we already run in production. Understand it will be production ready in version 3.1 coming soon. But we're always trying to explore how to make our lives simpler. Then if we look further on, you start seeing a lot of people start to trust their data processing to even serverless technologies like BigQuery and stuff. So we are keeping our eyes open in general. Yeah.
I see. Things you are talking about the HTAP. I think Ed has been really working on this for a long time. So from your perspective, Ed, what can TiDB help to really help the customer better to face these kind of challenges just now we mentioned? And what kind of roles can really HTAP can play from your perspective? You're unmuted. Yeah.
Actually, my feeling is we're talking a lot of technology, a lot of softwares, and I would say, engineers and people sometimes underestimate the power of simplicity. So, nowadays we have so many things to learn: Spark, Serverless, Hadoop, Hive, everything, ClickHouse, something like that. But I think it is not right. So I think the greatest value of TiDB HTAP architecture is just about simplicity. That can reduce the complexity of your technical stack. So imagine that if you have a storage system or a database that can cover about like 80% of application scenarios, that would be really nice, right? So just like smartphone. Nowadays we no longer have to carry a camera to take a picture or the iPod everywhere to listen to music. So just a smartphone to solve like 80% to 90% application scenarios. So that we can focus more on the business. We can more focus on our life. So I think it is the greatest value of TiDB. Can reduce we don't have to use a lot of things to fit the business requirements. So yeah, I think this HTAP value.
Nice. That's a very good one. But I think there are still challenges in a way, like when there's a hypergrowth. I think just now Ed mentioned like TiDB or HTAP can help you reduce the amount of engineers you need. But in a reality, Sean, when the hypergrowth scenario happens, like the shopping day and all that, how do you really make sure the team is getting prepared? Like how many engineers in reality you need to be on duty, and what kind of engineers you need, and how early do you really need to prepare this?
You're asking me, right? No?
Yeah, you. Yeah, sorry.
For us, is I said just now, we are very used to having these peaks, and then with the COVID, it's kind of like just a very unprepared thing. So in terms of how many engineers, honestly, the way we build our our architecture, application layer, everything else, Kafka, basically all distributed, those are very, very easy to scale. So we actually don't really have to do much preparation. And to be very honest, the only thing we always worry about is the write traffic. What's the QPS into the DB layer? So maybe we might need to try to vertically scale the machines or something like that at this point of time. But yeah, not honestly speaking, if you build it well, don't really have to do much. But you definitely need to have engineers on call 24/7.
Just now we talk about the real-time analytics, right? So where it used to be, there are so many different systems you have to choose from, Sean. For those systems, when you want to build like Spark, Hadoop, and all those, do you really have to add more engineering resources for that, or actually you think that's fine, your current team can really handle those?
I mean, the thing about like building a new technology, like before we have Spark, before we have Hadoop, there are a lot of things that we always try to do on the platform layer so that it makes it easier. So for instance, right now on our data ingestion into Parquet on GCS, actually we don't have to do anything because we have already created something very generic. As long as a new DB comes in, Maxwell takes that data, pushes it into Kafka, and it just writes the Parquet files into GCS. Yeah. So I mean, some effort is always required at the start, and you do it right, you build something that you don't have to keep on working on it when you need additional. Something like how you do DevOps, you just standardize it. You have new microservices. Is easy.
Yeah, nice. It seems like you already controlling well for the resources and get ready for the next spike. Karen, how about your side? What kind of team like you have been experiencing from PP perspective? how many engineers kind of needed for this kind of spike when it happens in terms of on duty and all that?
Yeah. So, like as I was mentioning previously about the promotional campaigns and all that we do, and we conduct regular tests. So, at the time of or on the day of actual campaign, or just before, when we have to scale out the system, because we are doing a continuous test and continuous limit checks, we don't really need the whole team or a lot of engineers to be present. But what we still follow is that we actually make sure that we have one or two engineers, basically the owners, or whomsoever is taking care of the microservice or the platform, be it TiDB, Kubernetes, Kafka, or the applications that we have. They are all part of it, so that everyone can get a feel of how things will be done for a specific campaign, and then we keep rotating this. So if we have to scale out, or if we have to support, or if we have to monitor some system, we just get one or two engineers from each of the team or each of the component that they are taking care of, to be part of that day's monitoring, or that day's scale out operations or things like that. And when we have this in future, and if we again, let's say, need to have similar operation, then again we rotate those engineers, so that other engineers should also get the feel of how things need to be done. One more thing that we do, which is very specific to TiDB, is that we actually inform PingCap members beforehand that we will be expecting a huge traffic, and we will be like, this is what our forecasted traffic is, and this is what we are doing for this. So if they have some expert advices for us, then they can share, because we always get to hear some more internals, or more like different properties of the storage layer, like around TiKV or around PD, and always like how we can tune it more. So that's why we tend to share it in advance only.
Yeah, that's the current experience, right? How about the in the past, before you adopting TiDB? How does that look like?
Oh, so that was okay. So it was very great, like I would say, roller coaster ride for us, because the day we had planned the migration, I still remember it was probably in the month of March 2020, when the coronavirus started to explode, and all our plans, which we had to meet together and continue all these tasks, were actually cancelled. So we did it online with the support of PingCap members and all. But then again, as TiDB handled a lot of difficult part for us, we did not really need to have a huge team. I still remember we had 5 to 7 engineers in all, taking care of the whole migration, right from copying data from our existing MySQL databases to new TiDBs, and then switching over the whole traffic. Apart from that, we indeed had people from PingCap as well.
Yeah.
But
So
then still it was not too much.
yeah, sorry to really cut it off. My question was more
No,
like before migrating to TiDB, right? You were using another cloud provider service, right? How does that experience look like compared to switching over to TiDB?
Oh, I see. Sorry, I
That's fine. That's fine.
misunderstood your
But
question.
that's
So
a good one.
before TiDB, yeah, before TiDB, we were using Aurora, the AWS Aurora. We still use AWS Aurora for some use cases where we have not introduced TiDB. So I would say that the experience is a little different, because Aurora is very close to MySQL. We did not really need to pay a lot of attention towards the distributed part, or the distributed nature that we have to pay attention afterwards. So previously, I would say we were not very much aware of database internals, or not, looking too much into tuning those parameters for us, because AWS has done it for us. But after moving, we are actually realizing more about the database internals and all. But then again, the team size, I think it's still the same. We are growing as a team, but not only because we are moving to TiDB, but we are just growing as a team. So I wouldn't say that we need so many engineers for TiDB.
Okay, that's really good to know. We talk a lot about the new SQL, guys. and also HTAP. So these new concept from the engineering perspective, do you foresee it can bring in any innovations to the business side? I think I will switch this question over to Sean to talk about that.
Yeah, of course. I mean, new SQL, new SQL. Yeah, sounds like NoSQL is out, new SQL is in. And especially we're talking about HTAP, right? One key thing I see about it is okay. First and foremost, I'm not very sure because HTAP is we are not very sure whether it's like the silver bullet, right? But there are definitely a lot of advantages I can see in terms of like business innovation. First and foremost, if the HTAP solution works, that means that we probably might not have to do the ETL from the OLTP to the OLAP, since it's being handled by the solution to the TIE Flash. What that also means is that in terms of like analytical stuff, we are going to be able to get it more real time, and that to me gives us a very huge advantage, right? If someone is doing T+1, I mean, and we can do it real time, yeah, lots of business advantage, right? Then specifically for us, when we are looking through the documentation, looking at the different ways to do it with TIE Flash, it's also like just now I said, right? Everyone in NinjaVan knows how to do SQL, so again, is something that immediately they will already be able to benefit from. And it's quite impressive because you guys have the cost optimizer, so you can do the smart selection to get it for the column store or the row store, and even very compatible with how we are doing our current Spark jobs on K8s with TiSpark, right? So actually, honestly, I'm not sure yet because we haven't really tried TIE Flash out, but yeah, I very interested to look at it.
You should try.
Meng Nan. Yeah, I'm waiting for Meng Nan to tell me that yeah, we can start to look at it, right? So, but yeah, in general, I feel that it can probably solve some of the use cases that we are trying to use. Just now inside my presentation, I was talking about that redash use case, which we actually the requirement is actually near real-time analytics, right? We could tolerate something like 120 600 seconds of delays or something like that, but a lot of it really needs close to real time. Yeah, so very excited to try.
Nice. How about Karen? What do you see the innovations can be brought in with each type of new SQL?
So in my opinion, because as the whole tech itself is growing and the user base for technology is growing, you have many services available on just a smartphone. So I think new SQL and HTAP are like actually playing a lot of role in it. With new SQL, of course, we get a lot of abilities to basically have a horizontally scalable and a distributed relational like database. So that's always a plus point. With HTAP support in the same database allows us to have many wide range of features that we can provide to our end users in the mobile app itself, which we couldn't have provided otherwise. Like we already started to explore this field more, where we can actually provide users features where we will be actually doing very heavy operations on the database layer. Like I can give you an example. So if you open the PayPay app, we have a section for transaction history. And in that transaction history, in the earlier days, you just used to see your history of what transactions you did sorted by your date and all. And you could just scroll down to load more and more. But then that's just a way where users don't really get to see how much they have spent over the month or over the year or throughout. Or if they want to filter out their transactions, that which store or which type of shop they have spent what money, they really couldn't do it in the app itself. But we have added this feature in our transaction history service. So what happens is that a user can go to that transaction history page and then actually can select a lot of filters where he want to filter out his results and his transactions, and he can actually iterate over the whole history throughout. So maybe right now, like till for 2 years, if some user is with PayPay since the beginning, he can actually filter out the whole 2 years of transactions and figure out what all filters he desire. At the same time, we also actually have prepared more of a transaction category kind of service where we actually show user his expenditures or how many transactions he has done over a month in forms of pie charts and bar graphs, and we actually categorize all these transactions in terms of the merchants or type of shops that they did. We actually categorize many other fields. So all this I think is possible because of the HTAP support that we get. Otherwise the response time would have been shooted like very high. So this is one feature that we have already introduced, and we see a lot of traffic on this feature as well. We see users actually using it with like very regularly. So we have a lot more in like in the planning that we could leverage this more analytical processing, and we could come up with more features which actually let the user intact with the service. So I think there is a lot of innovation possible, and I think we will soon release more similar features. So yeah.
Nice. Well, thank you so much for all the awesome answers. I think in the past few 30 minutes, it's only me asking the questions. We have 10 more minutes to run. So that's where I would like to open the floor to you guys to asking questions to each other. If you have any things, you may have a different question from different perspective from what you just heard from different panelists has been said about it. Yeah. Anyone?
I can go ahead. I have a
Good,
question for
please.
Ed.
Yeah.
So yeah. So like TiDB is so the whole TiDB clusters that we make. We have a lot of components, and all the components are designed to be distributed in nature. So how to choose whether to go for a multi-tenant setup like TiDB cluster, or to go with a multi-cluster setup? Like generally people have similar questions in Kubernetes, whether to go with a huge Kubernetes cluster with multi-tenancy. I have similar question for TiDB. Like how should we solve this problem?
Yeah, actually, you mean when to choose a super huge TiDB and do the multi-tenancy inside one single cluster, or set up multiple TiDB cluster for multi-users, right? Choose between
Yes.
these two kind of
Yes.
setup. Okay.
Yes.
I think that depends. For example, if you have many small and non-mission critical application you want to run inside TiDB, you can choose a large single cluster and do the multi-tenancy inside one cluster, because sometimes some problem like busy neighborhood is really painful, and also for example, sometimes if you want to upgrade your application upgrade your TiDB for like a single tenant, uh, that will be not very convenient if you put all the tenants inside one cluster. So if you have many tenants and for example, some tenants running very mission critical application, maybe you need a multi-tenant setup, set up multiple TiDB cluster for such scenarios. But if you have many non-mission critical, data is small, you want to reuse the hardware, you want to use the hardware resource as much as possible. You can use the shared cluster for this kind of applications. Yeah, so that's my point of view. And actually, I think there's another way. Is like you running TiDB on using TiDB operator on Kubernetes, and Kubernetes will for example in my design we want Kubernetes to handle the multi-tendency for TiDB, right? It separate the hardware and the logical cluster. So yeah,
Okay.
this is my recommendation. Yeah.
Yeah.
Understood. Thank you.
Any other question from the panelists?
Again, question for Ed. Just now you were mentioned looking at using object storage like S3 as storage backend for TiKV. Very, very curious in that. Is that already in development? Is there a roadmap for that? Very interested to find out more.
Yeah, actually, right now it is not already in development, but we are drafting this detailed design, and I think it is a very promising design, because I think we solved the problem that can balance the throughput of S3 provided by S3 and lower latency using local SSD. So the reason why we build this is we want to reduce the cost of using TiDB in cloud. So the whole design, I would say, that is inspired by the Snowflake. We're using the whole idea is like we put the cold data in S3 and the hot data using the local disk in the computing node, and the S3 is distributed, so we don't have to handle the data movement just like TiKV did now. So yeah, we will publish the more details about this, and yeah, you will definitely know that. Yeah.
Thanks, Ed. Yeah, very interesting because coming from a cost perspective and also availability of S3 GCS, that's great. Yeah.
Nice. Any other more questions from the panelists?
Can I ask Karan a question? How many MySQL instances or clusters are you migrating to TiDB or Aurora? How far are you? Is your goal to migrate everything? And how do you choose what to prioritize migrating?
Yeah. Okay. So, okay. Yeah. So, by far we have migrated almost, if I can quickly count, I would say four or five of our Aurora clusters already to TiDB, and we are planning to migrate more eventually. So about the priority and how we decide when to migrate which one. So as I said that we have a lot of microservices like similar to your architecture, but then we have different microservices which have different nature. So for example, few of our microservices are very write heavy. For example, the payment one which we have migrated, and we actually rely on bin logs for all the availability. So in case of write heavy service, the bin log is the one which becomes a bottleneck, and for that we actually needed to migrate them on a priority. That's why we went with the payment service migration in the beginning. Now after that, because we have seen really great performance, even we achieved much higher TPS than the current TPS that we have with TiDB. So we are planning on deciding which services we should take next. uh, then there are a lot of factors that we have to consider. There are some factors which is about if some new features are going to be released for a specific service. So let's say if we are doing some innovation around the online wallet that we have, so we have to adjust the schedule of migration. If we have something around the customer lifecycle management related features, then we have to prioritize those. So the priority accordingly matters. If there is a necessity which was there for payments, so we took it on the highest priority. Then the second factor we take is that what is the roadmap for the whole service and the feature plan that we have. Accordingly, we figure out which one to migrate.
Cool.
Nice. Thank you so much for all the discussions and sharing of the thoughts. I really appreciate that. So if there's one sentence you want to talk about to the community and your wishes to the community, what will be that be? This is our first ever event. It will be a long run to go. Please, maybe we can start from Changji. Yeah.
Okay. I wish that more and more people in the communication and the join and the share technology. Yeah.
Thank you.
Thank you.
How about Shang?
Yeah, I hope that this event will be continuous. I think this has been a great. I mean, getting to know all of you, sharing our problems. We are just on our starting out our journey with TiDB, and the more of us get involved, we can give our feedback, give our suggestions, share any problems, and we can get the product to be great, even better, faster.
Thank you so much. How about Karen?
So for me, I really want the community to grow even more, because you guys are doing a lot of invention and providing so many different tools and solutions to us, making our life easier. So I really want the whole community to grow even more, and we have more nicer solutions that we can utilize.
Cool. Last but not least,
all I want to say is thank you all of you. You are making TiDB better, making this a really great community. Just thank you. Yeah.
Thank you everyone for attending this session. For me, I don't know your feeling, but it's really been a great session for me. Here, all the challenges and the solutions that the technologists and leaders has been really dealing with. I think in the past, it's a little bit challenge for everyone during the COVID-19 time, but there are tons of opportunities if you can ever observe on what's happening. And thank you again for attending. For our TUG APAC event, it will be a monthly event. As Sean wishes, it comes true. We will have a next event coming up on the 27th of November. So we already can confirm one speaker who is Manov from Tokopedia, the VP Engineering from Tokopedia. Again, scan the QR code, join the Slack channel, share what topics you want to hear from the community or from which speakers. We will try our best to invite them over and talk about their technologies and experience. With that, gonna see you next time. Thank you again for your time for Friday afternoon. Bye-bye. See you next time.
Thank you. Bye.
Thank you. Thank you, everyone. Bye-bye.
Thank you.
Bye.